The Mach reactor has been described as a revolutionary metallurgical technology. What is it and how does this technology work?
Now, the Mach reactor is actually cavitation technology, or it can be viewed as a picobubble generator, and can be utilized in the flotation industry, particularly with the flotation of fine minerals, which is ordinarily lost out to tailings. It can also be used in the leaching side of things, gold leaching or base metal leaching, where we'll improve efficiencies and also the dispersion of gases, which is critical for leaching.
You have mentioned two applications, that is gold and PGMs. In terms of application, what are the applications that this technology can be applied?
It's actually a worldwide, worldwide application in terms of the the field, the geography, if I can put it that way. It's a globally applied, and it can be applied to many other fields, such as zinc flotation, copper flotation, in water treatments, etc. There are probably quite a few other applications that people will still come up with on their own, but I think we are just scratching the surface at the moment. And we're in gold and PGM at the moment because that's my comfort zone, that's my experience. So I've been employing the Mach there and looking for clients in those industries.
I see. What are the benefits of the technology compared to conventional solutions that have been in the market?
So the huge benefits are, now the Mach is a cavitation unit. The other units which you can consider to be competitors are actually shear reactors, they're more static mixer technology. And the issues with those technologies, some of them as old as 20 years, is they tend to break, they tend to wear out, and hence they're very labor intensive for operators to keep on a plant. And the Mach solves all of those issues because the lifespan of the reactor is actually the length of the project, so the life of your mine, well over 10 years. And it's quite extraordinary in that regard, in that we don't have to replace any wear parts. In fact, nothing is replaced. You install it, commission it, and it runs. So the oldest ones we have running at the moment is 7 years, and it's one of the, the biggest differences between the Mach and other shear technology is the durability of the unit, and as well as the performance, because cavitation is a principle that's used in the Mach, but not in any of the competitive technology.
Yeah. What are some of the flagship projects where you have deployed this technology, and how did it make a difference then?
So I would say probably the strongest flagship I have is a PGM project here in South Africa that was on the brink of closure before speaking to me. And we went all the way through from test work phase all the way through to plant implementation. And we've managed to turn that project around financially. So it was at the brink of closure 5 years ago, but it's still operating very strong today. And I think that was something huge that we did, because they had already tried everything else by the time I got there. And I was told, if this doesn't work, we will close doors. So it was a good feeling to turn around an operation, to bring productivity back, to bring profitability back. That's the PGM operation here. And then there's a gold operation in Ghana where the guys needed to extend their leach circuit, so they needed capital to build more leach tanks, which they didn't really have. And I approached them and said, I can give you that leach kinetics so that you don't have to spend any money on capital. And we went in and did that also about 4 to 5 years ago. And to this day, they have not had to replace anything. So they're still running on an old circuit, but with much higher plant throughput, just by using Mach technology.
I see. What are the key differences between the shear technology and the cavitational technology, which is the Mach reactor?
So I think the main difference is the mechanisms that are employed. So shear technology relies on mixing, and the more mixing you put into it, you'll go from a bubbler to actual shear, but beyond shear is cavitation. It's at the pinnacle of mechanisms that you could possibly use. And if I give you an example, an imploding bubble temperature at the center of it is 5,500 degrees Celsius. The jet that splits that bubble is 1,000 atmospheres. It's extreme conditions. And you would have to ask yourself, well, why would you just rely on mixing if you can employ this degree of aggression? The key being you're going to employ that degree of aggression without it destroying your equipment. And that is one of the things we've mastered, as I said already. With the Mach, we have a hydrodynamic Venturi system, wherein we get the velocities going through those Venturis to approach the speed of sound. That's why the unit is actually called a Mach reactor. But in doing that, we also reduce instantaneous pressure to below water vapor pressure, and we start to generate water vapor cavities in the slurry, that is the heart of what we're doing. So for flotation, those cavities would generate on the particle that you want to float. It's almost like a particle giving birth to bubbles, and we're able to then float it. And for leaching, we will then ventilate those cavities with oxygen or with air, and as they break down into picobubbles, we then disperse that into the pulp.
With all that said, what is the value proposition to the customer?
Well, the Mach goes straight to the bottom line. And yes, it is fancy science, it's clever science, but at the end of the day, it's improving productivity for a client, it's improving his incremental profits. So at the end of the day, you are improving profitability of the organization, also sustainability for length of life of project, etc., etc. So what it comes down to is that improved profit, which every businessman understands. So even if you're not a scientist and you haven't understood anything about cavitation technology, but when you do talk to a businessman about increased profits, that grabs attention, and that is what we're about at the end of the day.
I think ESG is a hot topic in the mining sector as well. How does this technology help in contributing to reduction of carbon emissions?
So everything I've just explained about the Mach in terms of its durability, the fact that you don't need to do maintenance on it, you don't need to interchange out wear parts or anything like that. You install it once at the beginning and it runs for the whole life of the project, compared to other mixing or shear technologies where you have to replace every month, every second month, involving, it's a ton of equipment involving cranes and fitters. And it's a lot of duplicated work, which at the end of the day translates into a bigger carbon footprint. So with the Mach installing once, that carbon footprint is reduced right down. You're not flying equipment all around the world, you're not flying people all around the world. Just that improved efficiency, we're able to reduce the carbon footprint, but also on the environmental side, we're using the Mach reactor for cyanide destruction. There's an application also for acid mine drainage treatment. So there are ways that the Mach can be employed that's not probably directly related to profitability, but it can be used to make the world a better place.
Thank you.